Let's solve one problem. Let us solve one problem from uh, quantum physics. The problem states that this series limit wavelength of Balmer series in hydrogen spectrum is exponentially found to be 3646 angstrom, and we will need to find the wavelength of the first line of this series. So we are given the series limit wavelength of the Balmer series, means series limit wavelength is given. So series limit wavelength is given as is equal to 3646 angstrom for n tends to infinity to 2. We are also to find the wavelength of the first line of the Balmer series. We are to find the wavelength of the first line of the Balmer series, that is the transition from equal to 3 to from 3 to 2. So first use the Rydberg formula. One by lambda equals to R by square minus 2 square. So for Balmer series, one equal to 2, and series limit implies equal to infinity. So we have so 1 by lambda infinity R into 1 by 2 to the power square, and 1 by infinity is 0, so 0, or equal to R into 1 by 4, or R equal to 1 divided by lambda into 4. Right. We will substitute lambda infinity is equal to 36646 angstrom. or R will get 13646 angstrom inverse. We calculate the wavelength for n equal to 3. This tool is to calculate let wavelength for n equal to 3. So 1 by lambda 3 to R into 1 by 2 square minus square equal to 4 by 6 1 by 4 9 will be around we'll have 131256 divided by 20. So we have 6563 angstrom. So the wavelength of the first line of Balmer series is the so the wavelength of the first the Balmer series. The series is approximately 6560 angstroms. So the problem, the solution is clear. So thank you.